All right, let's do this example of calculating pressure. And remember, pressure is defined as the force divided by the area over which that force is applied. So what we're told in Part A here, in Part A, well, we have this 60 kilogram person that steps on a 1 millimeter diameter nail. Okay? So in other words, what we have here is we have the entire weight of this person on that nail. So the force applied by that nail is equal to this person's weight. So that force is the mass times G, and that's 60 kilograms times 9.8 meters per second squared. And that gives you a weight or a force applied by the nail. That's 588 newtons. Okay, now to calculate the pressure, we need to know what the area of the tip of that nail is. So the pressure, which is force divided by area, the area of a circle, we're assuming this needle, the nail tip is circular. So for a circle of diameter d, the area is pi half of the diameter squared. Okay? So we can plug these values in here. 588 newtons divided by pi. Now 1 millimeter is 0.001 meters. Remember, we have to get everything into meters. And that is divided by 2, okay, for our 2 there, because this is diameter, and then squared. Okay, so when you do this calculation here, the number you get is 7.49. Let me move this over a little bit. 7.49 times 10 to the 8. Slide this over a lot more. And that's in pascals. Okay, so there's our result. And what is that in terms of atmospheric pressure? That's nearly 10,000 times atmospheric pressure. So 10,000 times atmospheric pressure. That is a tremendous amount of pressure, and that nail is going to puncture this person's foot, no problem. Okay, and so in Part B, we are considering that this person's lying down on a bed of nails now. Okay, so the person is now lying down on a bed of nails. Now there are 800 such nails. And you might think from, that this is still going to cause a lot of damage. But the pressure, again, is force divided by area. We have a force of 588 newtons. And our area, with 800 nails, we have 800 times the area from Part A. So, therefore, our pressure is going to be 1/800th of this. Okay? So, if it's 800 times the area, 1/800th of that is 9.36 times 10 to the 5 pascals. Okay, and that's more like 10 times atmospheric pressure. That's a very manageable pressure, and that's not going to puncture your skin. So this is a pretty good demo to do sometimes. If you have a bed of nails, you can lie down on a bed of nails and not have it do any damage. The reason it doesn't do damage is not because of the total force, it's because of the pressure. These 588 newtons, the entire weight of this person, is distributed across 800 nails instead of one nail. So when you distribute that weight on one nail, it punctures your skin. But when you distribute that weight over 800 nails, the pressure is considerably lower, and it doesn't puncture the skin. So just for a little bit of reference here, the human body often has pressures of about 10 to the 6 pascals in various joints and organs. So that's about this value right here. So our bodies are really designed to handle pressures of about this much. So this isn't going to puncture your skin. You'll certainly notice it lying on a bed of nails like this, but it's certainly not going to puncture skin. That is, if you do it right. I mean, you got to make sure you really distribute your weight on this bed of nails. You don't want to sit down with just your butt first. You really want to ease yourself onto that bed of nails so that as many nails as possible are supporting your weight. The way this is a lot of times done when people lie on a bed of nails is they lie down a towel down on a bed of nails as well. I sort of think of that as cheating a little bit. But when you see really good people who are really experienced in this, they really lay themselves down in such a way that they're having as many nails as possible hold their weight.